First question, the mechanism for the reaction is given below. The rate expression for the reaction is. Now, since we know that the rate law expression is given only on the basis of slow process. Okay, so by looking at this reaction, rate law is equals to K, concentration of both the reactant. Okay, so concentration of P and concentration of Q. Okay, so this is the rate law expression for this given reaction. Looking towards the option that R is equals to K, P into Q is there in option B, and thus the correct answer for this question is option B. Moving towards the next question, the minimum energy required for molecule to enter into the reaction is called potential energy, kinetic energy, nuclear energy, or activation energy. So the energy necessary for molecules to undergo chemical reaction is known as the activation energy. Okay, so correct answer for this question is activation energy. Okay, looking towards the next question, that in a photochemical reaction, the ratio of number of dissociate molecules and the number of quanta of absorbed energy is called Einstein, quantum efficiency, quantum constant, or Planck's constant. So the ratio of number of dissociated molecules and the number of quanta of energy absorbed is called as quantum yield, and it is given by the symbol phi. So correct answer for this question is option B, that is quantum yield or quantum efficiency. Correct answer option B. Looking towards the next question, the time of completion of 90% of the first order reaction is approximately. Now we know that first order reaction is given as K is equals to 2.303 upon T log of A upon A minus X. Now here it says about K is equals to, so since we require to find out the time of completion, we can take T is equals to 2.303 upon K log of, let's take A to be as 100, the whole upon 100 minus 90. Why? Because the 90% completion of the reaction is done. Okay, so this much is correct. So this become 100 upon 10. Now we can take this K in the terms of half-life. So since we know that T half is equals to 0.693 upon K, so I can put in this terms, and there is a constant value also given, so that is 2.303 into T half the whole upon 0.693 log to the base 10 of 100 upon 10. Okay, so this 0 and this 0 can cancel, and that becomes log of 10. Log of 10 is 1, and when we solve this out, it becomes 3.3 into T half. Okay, so that is looking towards the option. If we see, it is 3.3 times that of the half-life, and because of this half-life given in the option, we have substituted this term instead of K, because we want the answer in terms of half-life. Okay, so correct answer for this question is option C, 3.3 times that of the half-life. Moving towards the last question, the minimum energy necessary to permit a reaction is. So it is internal energy, threshold energy, activation energy, or free energy. So molecules undergoing reaction should cross over the minimum energy barrier or energy level known as threshold energy. So correct answer for this question is option B.